I'm going to talk to you about wallets. And as for the previous presentation, I have all of the links in this document, which I'll share with you, so don't worry about taking links. And I'll be talking about wallet development. I work with Chaincode, you know that already. So, first of all, why should you care about wallets? It's kind of boring, right? You've had all this fun stuff about peer-to-peer and consensus and all the exciting node stuff. Wallets are just kind of boring thing on the edge, right? Maybe you're not even interested in Bitcoin Core. Maybe you want to work on Lightning. And I'm going to talk about the Core wallet for an hour or two. But I think you should care about wallets because it's the way that we humans interact with Bitcoin, right? It doesn't matter about all of this consensus stuff and the nodes doing peer-to-peer stuff if we don't have a way of using the network. So wallets are the way that we interact. And even if you're not interested in developing wallets, the way we think about wallets informs the decisions we make about the peer-to-peer network. For example, who is familiar with the taproot assumption?
Yeah.
Okay, what is the taproot assumption?
Okay, basically, if you have a lot of contracts with different branches, there is always a branch with an agreement between all the parties with all the parties making the contract. So you can aggregate it in an aggregate public key, and all the other branch will be dependent on it.
Yeah. So no matter how complex your script is, theoretically, you could get all the counterparties together to co-sign, and they should be able to aggregate their keys and make a single signature. Now, that's not the way they do that. Is not part of consensus. It's in the wallet, and the decision we make about the taproot design depends on the fact that we can do that, even though it's not part of consensus. Another example is sig hash anyone any prev out. Who's familiar with that? Or sig hash no input. Richard, what is that?
So it would be like a replacement, or it would do the purpose of 1.1.8, which is the no sig no input. So it doesn't sign the input, so you can reassign transactions to different compatible transactions instead of just one.
Yeah, and so we can integrate that into Bitcoin Core. We have kind of that high-level design, but a lot of the discussion is around how we can make it safe, how we can make it in such a way that people don't shoot themselves in the foot. And that's a consideration around wallets and how people interact with the network. So what I'm trying to say is, even if you don't care about wallets, even if you don't care about Bitcoin Core, you should care about wallet design and design considerations. All right, so fair notice. Unapologetically, I'm going to be talking about Bitcoin Core wallet because I don't know any other wallets. So sorry if you don't care about Bitcoin Core. And this presentation may contain traces of C++. So sorry if you don't know C++, but I'll try and make it understandable. Okay, so what is a wallet? What are the functions of a wallet? I didn't get as many as you. I had key management, transaction construction, and assistance. So what do I mean by those things? Key management, identify your own transactions, right? So if you have a wallet, you want to know when you get paid or when you pay someone. You need to generate new addresses, either for handing out to people for payments or generate new keys for change outputs. And you need to determine how to sign transactions. Under transaction construction, you've got to be able to parse addresses and turn them into TX outs. You need to select coins from your wallet. So UTXOs that you own, you need to choose which ones to use as inputs to your transaction. You need to sign them, and then you need to broadcast them. And advanced features like CPFP, RBF, batching, mixing, coin join, pay join, whatever those advanced wallet features you might want to use. And then persistence, obviously you need to have some kind of permanent storage to store your keys. That's obviously very important, but also to store your coins, so you don't need to rescan the blockchain every time you start your wallet. To store your transaction history, because you might be interested in payments that have come in and then gone, so coins that you've spent. And metadata, so things like labels, how far you've scanned through the blockchain and so on. So from a high level, that's what I'm going to talk about today. There's obviously a few other things that the wallet is doing, but this is really the core of what a wallet needs to do. Any questions about that? Thoughts?
Well, just a general question about wallets. Do wallets identified, are their user agents different than the command line node? So can you distinguish between a node that's running with the UI versus command line?
No, the wallet is not interacting with the peer-to-peer network. So you have your node, and the wallet is behind the node.
So when you launch the UI, it's not running the actual node?
The UI is running the node, yeah.
Oh, it is, but it's out of process. It's a separate
It's the
process.
same process. It's a different component. If you like, there's a well-defined interface between Qt, which is the GUI, and the node.
Okay.
So when you run Qt, it's running everything the same, except you also have a user interface.
Gotcha. Okay.
Okay. So before we dive in, I'm going to do a quick glossary of terms and objects in the wallet that you'll need to know about as we go through. I'm going to talk about initialization of the wallet and the interfaces into the wallet. When looking at a new code base, I think these are probably the best places to start. See how it starts up and see how you can interact with it from outside. I'm going to talk about code management. So where this code lives, where the files are, key management, transaction construction, persistence, and then future directions for the wallet. Okay. All right. So, what is a pub key in Bitcoin? Should be an easy question. Luciana?
Address that you can use to sign transactions, or it's the pub key can also be the script that you can use. A way to sign to receive funds.
Okay, you do need a pub key to receive funds. What is the public key itself?
A point in the elliptic curve.
So a point on the SecP 256K1 curve. And in Bitcoin Core, we have this object, this class cPubKey, which is an encapsulated point on that SecP curve. All right, what comes with the pub key?
Private key.
Private key, okay. And what is a private key?
It's a random.
Scale right there.
Hopefully a huge ass number.
It's a big ass number. Yeah, okay, it's a scalar. Private key kept secret and used to sign. And it's a scalar in the SecP 256K1 group. And in Bitcoin Core, that is a class called CKey. Okay, and that's in source/key.cpp or source/key.h. It's in the header file. All right, next up we have this thing called a CKey ID, which is the hash 160 of that public key. So that's the hash used to create the pizza pub key hash output type. And that's also how we identify keys in the wallet, how we index them. And that is, it's a uint 160, so it's a 160-bit number, and the class is CKey ID, a reference to a C key. And finally, TX destination, and that's a script template with a specific destination. And that's stored as a variant. So that can be any one of these types. No destination, key ID, so that would be a pub key hash. Script ID, so that would be a P2SH. Witness key 0 script hash, that would be a P to witness script hash. Key hash or witness unknown for a future segregation. So when we look at an output, we try and match a template type to it, and we say this is a key ID or witness V1, V0 script ID. So as we're receiving transactions and parsing them, we want to be able to identify what kind of output it is. That's where the matching happens.
So is it?
I was going to say that that's not the full list of everything you can send to in Bitcoin. It's just the list of what the wallet can send to, right?
What a wallet can receive, yeah.
Or receive.
Yeah, you can send to any arbitrary script, but these are templated script types.
So this is part of the transaction output, or the
transaction output
Yes.
is passed into this structure.
So each transaction output has a script pub key, and that script pub key can be any kind of script in the Bitcoin scripting language, but the ones that we recognize in the wallet and that we use in the wallets all fit under these templates.
Okay.
Or multi-sig, I didn't have multi-sig on there.
So pay to pub key is completely removed?
Let's see. Not sure.
I think a lot of miners still mine there.
Pay to pub key. So let's talk about initialization in interfaces. It's really exciting. The wallet components initialize through the wallet init interface, and that lives in source/wallet init interface. It's just a interface class called wallet init interface with 4 methods and a deconstructor. Has wallet support, add wallet options, parameter introduction, and construct. So this init interface is for starting up the wallet component. So for builds with wallet, the interface is overridden in a file in source/wallet called init.cpp. And here it is, it's called wallet init. It inherits from wallet init interface, and it actually implements those virtual interfaces. For disable wallet builds, this wallet init interface is defined in source dummy wallet. Right? So you have this dummy wallet init, it overrides that wallet, or it inherits from that wallet init interface, and all of these methods are basically just null, they're not true or don't do anything at all. And then those interface methods are called during node initialization. So in source/init.cpp, you get this global wallet init interface, and it calls construct or parameter interaction or whatever. So the reason we have this dummy class when we define it is that it means we don't have a bunch of if-defs all over the initiation function. So this is the same call whether it's a build without the wallet or a build with the wallet. It's just without the wallet, so this would be a dummy interface, and with the wallet, it will actually construct the wallet component.
So there's only one user in that sense for that interface.
Yes. Any other questions on that so far?
I have another question, just more history.
Yes.
When the source code was initially released, was the wallet like the entry point, like the UI, like the entry point, and then all the code was built into it and then extracted to create the daemon?
It was all mixed together.
It was all mixed together.
There was no separation at all. There's wallet code within main.cpp.
Okay.
Like node calling into wallet code, wallet calling into.
Like you couldn't run one without the other in the initial release. I guess.
I don't think so. Yeah, I don't know when disable wallet was introduced, but I imagine the initial version didn't have that.
Okay.
So the separation into this wallet interface seems to be recent, right? 2017 or something. Is this a direction we're going into where pieces of the code get broken up into interfaces and components?
Yeah.
Okay.
And even separate processes.
Yeah.
So that if there's some vulnerability in your wallet process, you can't get to the node or the other way around. Especially I think the networking code is kind of scary.
Yeah.
So if there's some problem with the networking code, then hopefully that cannot get to your wallet code. I think that's the idea of process separation. And just having things on different machines maybe.
Or even different VM.
Yeah.
I mean, we have a peer-to-peer stack.
Yeah.
We may run on VM and connected like with an IPC to the wallet or something.
Yeah, for me the dream is still that, right? You run a node on some device somewhere, but you have a nice graphical interface on your computer, and that somehow connects and all works. I think.
Yeah, we'll get onto that
Yeah.
a bit later. James?
I'm trying to understand why is there a interface specifically for the knit part of the wallet interface. If we build with disabled wallet,
Yep.
you would think the entire wallet interface would need to be
That's a good point.
included.
Well, this wallet in its interface is defined in the node code, and then the wallet code inherits from there and actually implements that interface. Or if you build without a wallet, then the node code implements that interface as a dummy.
Yeah, because there's probably some interface between the RPC calls and the wallet as well.
Yes.
That would also need to be,
Yep.
in quotes, dummied out because you're building without the wallet. But that's not part of the wallet in the interface. That's a separate interface.
Yes.
Okay.
Yes, and we'll get onto that.
Okay.
Okay, so we've constructed the wallet component, and now we're going to load the actual wallets. So wallet init construct adds this client interface, and the node then tells the wallet to load start stop through the chain client interface. So this source/interfaces directory contains all of those interface definitions between the node and the wallet, and between the GUI and the node. So let's have a look at that. Chain client, and that's telling it to do various things like load, start, flush, stop. Okay, so this is for loading individual wallets. Most of the methods in that interface call through functions in source/wallet/load.cpp, and as you probably can imagine, this file contains all of the loading code, so verifying the wallets, making sure that the wallet files are not corrupt, loading the wallets, starting the wallets, flushing them, stopping them, unloading them. Okay. Node wallet interface. So the node holds a wallet import interface to call functions on the wallet, and the wallet holds a chain import interface to call functions on the node. And again, those are defined in source/interfaces. So this wallet import has methods like lock, unlock, change wallet password, backup wallet, get pub key. And this is actually used by the GUI. So the GUI connects to the node and calls wallet functions through this interface. And then if the wallet needs to call functions on the node, it uses this interface to chain. And that has things like find block, find coins, has dependency mempool, check chain limits, it's ready to broadcast. So anything the wallet needs the node to do for it is called through this interface class.
Why would the node need to call into the wallet?
It's only for the GUI, because the GUI doesn't connect directly to the
It's
wallet.
like notification, maybe.
The notification zone? I mean, it's not polling. And
It's not notifications, this is just for the GUI.
Just
The
for the GUI.
but the
wallet
node
import is just for the GUI connecting through the node to the wallet.
pull through the node to the wallet. I see. Doesn't. Yeah.
So the wallet never calls through the RPC path to the node. It's got its direct interface.
Yes. Its wallet does not call RPC functions on the node.
So in the process of potentially separating the wallet, this interface would die, or
No, this interface is what will be used. So we, instead of it being a functional call interface, it would be inter-process call. And it would use the same methods.
Well, you could look at things like the GUI could call the wallets directly rather than calling through the nodes, that type of trade-offs, but I guess this was just done to make it easier.
Okay. So this might make things easier. So you have your node in your wallet. You have the GUI, which calls through the wallet, through the node into the wallet using that wallet import interface. The wallet calls into the node using the chain import interface. And I haven't mentioned this yet, but within that chain import, there's a notifications handler, and that's for all of the transactions coming to the mempool and you need to be notified, or when a block comes in and is connected and you need to be notified. That happens through that notifications handler.
So the wallet, there's like an implicit dependency on the node, like
Yes.
you can't. It's not a standalone.
No, I think that's kind of permanent.
permanent?
Well, because the node is where the consensus is. And so the wallet needs to know what the consensus is in order to do anything meaningful. So it has to assume a node, unless you would say, oh, let's make a generic wallet that other implementations could use, but I don't see Bitcoin Core doing that. That doesn't make a lot of sense.
Yeah, let's park discussion of what happens in the future until the end. Let's talk about how it is now, and then we can get into like the future potential.
Just so I'm understanding, the notification handler element?
Yes,
Is that in addition to the validation interface, or is it that the validation interface?
it's a validation. I'll go back and explain it, but I want to put this diagram up because people are getting a bit lost, I think. So this is kind of what it looks like. There's one way for the GUI to call into the wallet, which is this. There's one way for the wallet to call into the node, which is this. And there's one way for the wallet to get notifications, which is this. And then obviously there's an RPC directly into that.
And how does the GUI? I guess the GUI gets notifications about changes from the node, or through that wallet interface as well.
Not entirely sure about that.
I think that bounces around a few times from what I see with these notifications from that end up in the GUI. But I also don't remember how.
So what's your question?
How does the GUI get updated get notifications from either the node or wallet about changes from the network, transactions, blocks, stuff like that?
I don't think right now the GUI is implementing the verification interface, so
No, it's not a notification interface.
yeah.
It does have some interface to get notifications.
I know it's somewhere because obviously
Yeah.
it updates from blocks to downloaded.
I don't have that. I don't know right now, so I can
Okay.
look about a few days now.
Is the RPC talking directly to the wallet and not through the wallet info?
It is not talking through the wallet import, it's talking directly to the wallet through the RPC server.
Okay.
During initialization, the RPC gets plumbed up to the wallet.
There's a few calls to register the wallet RPCs on the RPC servers. So, right.
And then the chain object is a separate object. It's not part of the node, looks like. Right? We have the chain implementation.
This chain import is an implementation of the chain interface. Yeah.
Okay, but
So
it's
all
not
of
part of
like-
the node.
All of the like chain states and mempool stuff lives here in the node.
There is also the node interface, the node implementation interface.
Yeah, but we're not going to talk about that. Okay, let's go back. Okay, so the node has the wallet import to talk to the wallet. The wallet has the chain import to talk to the node. And then the third piece is that the node notifies the wallet about new transactions and blocks through the C validation interface. So this C validation interface is in source/validation interface.cpp.h, and this is an interface for any interested party to register for notifications for changes to chain state.
This might be a basic C++ question, but I see that here you have virtual functions and before you didn't have.
No, they were virtual.
They were also virtual?
Here,
Yeah.
here it's not equals 0, so here you don't have to override. There you have to.
Yeah, so we never instantiate an object of this class.
Okay.
We always inherit from this class, and then
So
instead-
that's why it's
that's
so
where
virtual.
these methods are overridden.
And when it's equals 0, what does that mean?
It's
It
an
means it's
abstract
not
class.
defined. There's no definition for that.
No?
So if it's has to be recognized. So if
Yeah.
it's equals 0, you have to provide overrides for all of them.
Or
Here,
it won't compile if you don't?
if you inherit this class, for example, if you inherit this class that we have on the screen, you don't have to provide overrides for all of the functions because they're not
Just
equal
what
to
you
0.
want.
Yeah, exactly.
Okay. Thanks.
Okay, so that's the interface, and in this is validation interface.h. It's got good comments on what all of those methods are, and then this notifications handler import is inheriting from that interface and overriding the functions that it's interested in. So the functions that the wallet is interested in on that notification C validation interface is transaction added to mempool, So obviously your wallet wants to know whenever a transaction is added to the mempool, in case that's a transaction that it's interested in. When a transaction is removed from the mempool, when a block is connected, when a block's disconnected, when the block tip is updated, and when the chain state is flushed.
So basically, the chain state and the mempool, two things are interesting.
Yeah, of course.
So this is fascinating to me. So we have all these handlers that are queued up. And when they, let's say this event, new block tip occurs,
Yeah.
All these handlers are called. They're called in sequence.
Yes.
But why?
What do you mean?
So if I have 10 subscribers,
Yep.
there's one event. Why is it important that these 10 handlers are called in sequence in that queue? Why can't they be called concurrent? Like, what's the design?
Because we only have one thread. So some of these are asynchronous and some of them are synchronous. So let's have a look.
You mean like every subscribers to validation events could have its own stack of events on its own thread?
So every subscriber has one handler?
Yeah.
Or multiple, doesn't matter. But they will then register these handlers to the signal or whatever. And when they register it, they have to be registered in sequence. They have like slots, numerated slots.
Yeah. I know the way.
Right? So when the event is called, when the signal is called, these are executed one by one by whatever thread is calling the signal.
Yeah, but every component needs to see the same consistent view. I mean, the event has to be in order, but not between the different components. I mean, maybe the peer-to-peer stack could be in advance.
Exactly.
Okay, yeah. Because it's not implemented yet, I think it's not easy to do.
You could potentially do something like that. The way it's implemented in Bitcoin Core is that some of these are synchronous. So I think chain state flush, the main thread, which would be the message handler thread, will call those callback functions directly. And the background thread methods will be called on
The scheduler.
the scheduler thread, right? And we only have one of each. So potentially you could make it multi-process, but not multi-threaded, but we're not really optimizing for having your wallets, having like 50 wallets
Because I was thinking like
in
if
parallel.
I'm a miner, there's a new tip. I want to make sure that my handler for the block template is on their top of that stack. No?
Yeah, you're probably not going to be running multiple wallets on that same node. I don't know.
Yeah.
It seems like an over-optimization to try and
I'm just
make
wondering.
that multi-threaded. At this point, you might be thinking, why? Why all of this weird indirection? Why?
It's modularized. It's good.
It's modularized, it's good.
Yeah.
Any advances on that?
I mean, if you have different process, you may have, use some kind of Unix tricks to read only some part of your private keys and not let, different policies, write policies, and thanks to your file system, and that will not be the same policies as your chain process.
So there are no functional calls between node and wallet, and a well-defined interface is easier for us to reason about. It means that if we make changes to wallet code, we're pretty sure that we're not making changes to consensus code. Whereas if there are functions calling into each other across that boundary, then it makes it much more difficult for us to reason about those changes. Individual components could be tested in isolation. So we could potentially build a wallet library and test it. If we don't, but we could. And in future, we could separate the wallet into a separate process, which would be good for security, because you wouldn't have your private keys living in the same memory space as the networking code. And then potentially, maybe we could open that API up, make it public, and other people could implement wallets to plug into a Bitcoin Core node. That would be way off in the future. So that's what it looks like. And like someone said, this is pretty recent. These interfaces only got merged maybe 3 to 6 months ago. So we now have nice contained wallet code, and it's a lot friendlier to work on.
So before that, it was just
It
random
was
Long
just
Java.
functional calls, yeah. And the node was making functional calls into the wallet, the wallet's making functional calls into the node. I'm going to run through code management. This will be 5 minutes, and then we'll take a break. So let's have a look at the wallet directory. Can you read that at the back? Just about big enough. So in source wallets, there's a few files. There's a test directory for unit tests, but there's not much in there. It's not huge. We have coinselection.cpp and .h, which is the branch and bound coin selection algorithm. We have crypto.cpp and h, which is the code for encrypting the wallet's private keys. Wallet db.cpp and db.cpp and the header files. That's interfacing into the wallet's Berkeley DB for persistent storage. Init.cpp for initializing the wallet module, and load.cpp for loading up individual wallets. RPC wallet and RPC dump.cpp for the wallet's RPC methods. Wallet tool is a standalone wallet util. And wallet CPP is everything. And anything else. So if we look, I'll get to your question here. So if we look at the line counts in here, coin control, pretty small. Coin selection, 300 lines of code. Crypto, 300 lines of code. DB and then wallet DB together, maybe 1,500, 2,000 lines. Fee bumper, that's for bumping fees, another 300 lines. So fee bumper, crypto, coin selection, coin control, these are all pretty small self-contained functions. In fact, coin control is just an object. Fees, init load, pretty small. PSBT, pretty small. That's for the partially signed Bitcoin transaction format. RPC code, you can see pretty big. That's maybe 6,000 lines of code. That's the main interface to the wallet from the command line. Wallet.cpp, 4,500 lines. So that's where the bulk of the logic is. Wallet tool, standalone tool is like 150 lines, nothing there. And then wallet util is just utility functions. So.
I think
Hugo had a question first.
Okay, so for encrypting,
Yes.
is there like a common encryption library, or do we use some of the crypto libraries, or does it have its own thing?
case
Sure,
true.
I haven't really
I
looked at
think
it.
it's with CAS, CIPA's implementation of AES. Like all of the encryption of the wallet stuff.
Okay. Yeah, and it's just encrypting the private keys.
Yeah, I mean, I think we need to add also keystore.h and keys.h because that's used.
Yeah, so there's other stuff, other code that the wallet is calling, which is not in this directory. So like is mine, signing interface,
Yeah.
that's in
Signing.
source/script. Right. So yeah, maybe I should include some other files here. So the signing interface
It's
is
bigger
Is that the wallet descriptor?
in script
we-
descriptors.
Yeah, we don't have wallet descriptors, or we don't have script descriptors in the wallet yet, or not fully implemented. What we use right now is a function called isMine and a signing provider, and those are both in source/script/something.
Except for import, where we can handle the scriptures.
Yep.
But they're translated to the old style of the wallet.
The wallet file, wallet CPP, do you think there's more things that should be extracted out eventually, or is it pretty good as it is?
Potentially we could extract more out from that. Yeah, it used to be like everything was in wallet CPP.
This might be too early, but I've noticed there's a lot of activity around isMine.
Yep.
What's maybe a general context?
I'll talk about that later.
Great.
Any other questions on source code?
Wallet.h is like also mostly then gluing the other parts together, right?
Yeah, .h is the header file, and so that will contain all the declarations for the classes and functions, and then the implementation of those classes and functions will be in the .cpp generally.